Hello everyone, welcome to Pepcoding. So in this video, we are going to start the next question of our series. So the question we have this time is quick select. Okay, so let us see what the quick select is. We are going to code this in Python. So let us go to the board and see what the quick select is. So in this quick select, we'll be given an array. Okay, first of all, we'll be given an array and we'll be given a number k. So we need to find the kth smallest element. We need to find the k smallest element. Suppose we have an array that is like 5 3 1 9 4 2 0. Okay, we have this. So what we'll do is we need to find, suppose k is equals to 3. Okay, we need to find the third smallest element. So we are going to use partitioning for this. Why partitioning? Okay, first of all, we know that what we are going to do in this question. Okay, what we have to do in this question, we know that what we have to do, we'll be given an array, we'll be given a number k. We just have to find the kth smallest element in this array. So what is the kth smallest element? Let me tell you once again. So kth smallest element is, suppose if this array is sorted, then it would be like 1 2 3 4 5 6 7. Okay, that's enough. If it would be sorted, then it would be like 0 1 2 3 4 5 and 9, like, right? It would be like this. Then what would be the third smallest element? First smallest is this, second smallest is this, third smallest is this one. 2 is the third smallest number. So this is what we have to return. 2 we have to return. Answer is equals to 2. Okay, not like this, just this 2 you need to print. So how we are going to do this? So for this, what we are going to use is partitioning. So how partitioning will be used? See, we have already observed in our quick sort that when we do partitioning of an array, then the partitioning index at which the pivot index would be. First of all, let us discuss what we used to do in partitioning. In partitioning, what we used to do is we take a pivot, right? We take a pivot and around that pivot we do partitioning. And after partitioning, what happens? All the elements that are greater than that pivot comes to its right. All the elements that are smaller or equal to that pivot goes to its left. So this is what happens in partitioning, right? We already have discussed partitioning in the previous question. Okay, in partitioning of an array question. Will not discuss more about it. So let us move to our actual question, that is quick select. So how we are going to find the third smallest element? Third smallest means the element that will be in the second position. See, this is in the second position, right? It is the third smallest element, but the index of this position is second in the sorted array. Second in sorted array. This is what I'm saying. In sorted array. A word in sorted array. Okay. So this is what I'm using. So this is what you have to catch, that what is the meaning of this. Okay, so when we do partitioning, what happens is this pivot goes to its sorted position. So suppose when I'm doing this partitioning, suppose I'll do the partitioning first step. Okay, so what will happen here? Let us see. If I'll do partitioning here, then we will get all the elements that are greater than 0 will be in the right. So all are greater than 0. So 0 is the pivot here. So we'll have 5, we'll have 3, we'll have 1, 9, 4 and 2. Okay, so this is what we will have. So now we received after the partitioning, we receive a partitioning index, that at what index it is. So it is at the PIDX for this would be 0, right? This PIDX would be, partitioning index would be 0. So that means what it is saying, what this means is that it is saying that this pivot will be at the 0th index in the sorted array. In the sorted array, this pivot will be in the 0th index only. Okay, because all the elements that are greater than 0 are on its right, and all the elements that are smaller than 0, which are not available right now, are on its left. Okay, so this is what PIDX or the partitioning index is saying. So now what we have to do? What we have to do after that is we need to find the third smallest, right? Third smallest. So third smallest, third smallest will be at what index in the sorted array? In the sorted array, third smallest element would be in the second index. This is what you have to understand. This is what you have to understand, that the third smallest element would be in the second index. Why? Because see, if this array would be sorted, I already have shown you, let me show you again. I already have shown you that, yeah, this, see, we need to, this is the sorted array of this, right? This is this array. If this would be sorted, then this would be like this. Okay, so if we will find the third smallest element in this, then it is in the second index. Okay, second index in the sorted array. So we just need to find, if the question is saying find me the kth smallest element, then what we will do is we just need to find the k minus 1 index element in the sorted array. K minus 1 index element in the sorted array. So this is what we need to do. So let us find it. How we are going to do this? Using partitioning. How? Let us see again. Do the partitioning for this first of all. This would be like 0 will come here, and 5, 3, 1, 9, 4, 2 will go like this. Okay, this will go like this. It will become this array. It will become this array after the partitioning. So now I receive that PIDX equal to 0. That means 0 as its sorted place. But I need element that is in the second index. Right? I need element that is in the second index, not third index, but second index. So this k to k minus 1 is already handled in our main. Okay, this is what you have to understand, that we already have handled that. This, you just need to find this position, this index element, this k minus 1 index element, and that is already handled. You don't need to find kth smallest, or you don't need to care converting k to k minus 1. We already have converted k to k minus 1 in this main. Okay, we just have passed k minus 1. So just find the kth index element. Okay, kth index element, that would be enough. Okay, that would automatically give you k minus 1 index element. Okay, because we already have passed k minus 1. This is what you have to also understand, that what is happening in main, and what am I telling you, that third smallest means second index element in the sorted array. Okay, so let us continue. So now here we have partitioned, right? Now we have partitioned, so we got this array. Now where I would go to find the second index element? If I'm at the partitioning index 0, where would I go to find the second smallest? I'll go in the right? I'll go in the right side. So what I'll do is, I'll go to the right and I'll say take this as the pivot. Last element will take as the pivot, right? So take this at the pivot and arrange them according to the partition. So I'll arrange it. So what it would be like 0 will only reach 0 will be like the same 0. Okay, because it is already sorted, no need to touch it. Just pass this from where it is, from PIDX plus 1 to high. Okay, right side means PIDX plus 1 to high, left side means PIDX minus 1 to low to PIDX minus 1. Okay, that would be left side, and right side I already have told you. So let us take this as the partition and do the partition. So after partition, it would be like all the elements that are smaller than 2. That means 1, then 2 will come here, and then 3, 5 will come first, then 3, then 9 will, and then 4. So this would be like this: 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. Okay, so this is what we will receive after doing the partitioning again. So we need this time the partitioning index that we received is 2, right? Is 2, and what we wanted is, we wanted the second index element only. So we received the second index element. So this is what we need to print. Simply, if PIDX equals to k, then simply return the element and print it. This is what we need to do. This is what we need to do. So I hope that you got that what I am trying to do. Okay, and this would be more clear when I'll write the code for the same. Okay, so let us go towards the code. Okay, I hope that you understood this one that in this, first of all, I did partitioned and I taken this pivot to its sorted position. Again, I checked that at what side should I go. I should go to the right side, okay, because I'll get the second index element on the greater element only, because I'm at the zeroth index element. I'm at the zeroth index element in the sorted array. So go to the right. Go to the right because there are greater element which could lie in the second index in the sorted array. Okay. So here I just have taken a pivot. Okay. And that pivot came to its position, and that position would be the second. That position is second position. So what I have to do is I just have simply return that. I'll just simply return that because it is my element in the sorted array in the kth. It is the kth largest element in my sorted array. Okay, so kth smallest again. So what I was doing is, first of all, I was taking a pivot. So pivot was the last element, right? Array at high. This was my pivot. So and the semicolon is up to you. If you want, then you can use it, otherwise there is no need in Python. So let me increase this editor. Okay, and after the pivot, just do partition on the basis of this pivot. Partition on the basis of this pivot. Give it array, give it pivot, give it low, give it high. Pivot, give it low, give it high. Okay, these four, right? It will return me a partitioning index. Save it. P idx equals to this. Save it, and then check if okay, in Python what we used to do is this, right? If p idx is equals to k, if it is equals to that index which we need to find. Okay, we already have passed index here. Okay, k-1 is the index, so we just need to find if it is that equals to that index. If it is equals to that index, then simply return arr at pidx, right? Simply return arr at pidx. Otherwise lf pidx could be greater than k, right? Pidx should be greater than k. So when it is greater than k, then at this case, where I need to find c, let's go to the board again. I received a partitioning index, suppose 5, but I need second smallest. So where should I go? Should I go to the right where all the greater elements are there, or should I go to the left where the possible smaller element that could lie on the second index would be there? So I'll go on the left, right, where the smaller element are, because I need second smallest element. I mean the third smallest element that would lie in the second index. So I need a second index element. So I'll go to the left. When pidx is greater than k, when partitioning index is greater than k, okay, that means that I am away from the in the forward direction of that of my original index element, right? So I'll go to the left. So how to the left? Just go and return quick select and pass it. Left means array low and pidx -1. This is what the left is, right? Pidx -1 and again k, pidx -1 and again k. Okay, so this is what you need to do, and then else simply return quick select, pass it array, pass it else means pidx this time is smaller than k. Pidx is smaller than k. That means my k is lying this side on the right side. So where should I go? I should go to the right. So go to the right means pidx plus 1 2, pidx 1 plus 1 2, go to the high and k. Okay, so pass this. So this is it, and Do we need any base case? No, we don't need any base case. Why we don't need any base case? Every time we are returning, okay? Every time we are returning in every case, every condition, in every condition we are returning. No need for base case. Let us give it a run and check if it is running correctly. Yes, it is accepted. Let us give it a submit to check if it is running for all the test cases or not. Yes, it is running for all the test cases. So I hope that you understand this logic, you understand this concept, you understand that in a sorted that in a array, when we apply partition, the pivot index that we get, is the index of that pivot in the sorted array. Is the index of that pivot in the sorted array. This is what you need to understand. Okay, this is it. Just a simple question. We'll meet in the next question now. Till then, goodbye, take care, and don't forget to like this and also subscribe the channel, share it with a friend, and goodbye, take care.